Hello viewers, in today's session we are going to discuss a very interesting problem from derivatives, and here we are going to solve this problem where we are given a function f of x that is equal to the absolute value of sine 2x, right? And we have to find the derivative of this function f of x at these 2 points, that is x is equal to pi by 4 and x is equal to 2 pi by 3, right? So this problem is going to be very easy, and here we'll apply two important concepts. The first one is the definition of mod function, and then we'll see the concept of derivative as a tangent line to a curve, right? That is the slope of the tangent is given by the derivative of the function at the given point. So let us start. So let us first quickly see the definition of mod function. Now a mod of p is defined as positive p whenever p is greater than 0, and a mod of p is equal to 0 when p is equal to 0, and mod of p is negative p when p is less than 0. So let us first apply this definition to this function. So here we have f of x is equal to a mod of sine 2x, right? So mod of sine 2x, so here we can replace this p by sine 2x. So we have mod of sine 2x is positive sine 2x whenever sine 2x is greater than 0, right? Because this concept is going to be very important while solving these type of problems. And here a mod of sine 2x is equal to 0 when sine 2x is equal to 0, and mod of sine 2x is equal to negative sine 2x when sine 2x is less than 0, right? Okay, so now here we'll first derive some results from these three expressions, that is these two inequalities, and here we have a trigonometric equation, right? So see, sine 2x is greater than 0. Now sine 2x is greater than 0 when this 2x it lies either in the first quadrant or in the second quadrant. So here if we draw the quadrants, then we have here 0, here we have pi by 2, here we have pi, then we have 3 pi by 2, and here we have 2 pi. Now this is the first quadrant, this is second, this is third, and this is fourth. And from the sign convention of trigonometric functions, we know that the sine function is positive in the first and second quadrant, and the sine function is negative in the third and fourth quadrant. So now sine 2x is greater than 0. It implies that sine 2x should be positive, right? And this happens only when 2x it lies either in the first quadrant or in the second quadrant. So we go from 0 to pi. So when 2x is greater than 0 but less than pi, then sine 2x is greater than 0. So here this inequality can be written like this: dividing throughout by 2, we have 0 over 2 is 0, 2x over 2 is x, and here we have pi over 2. So now we can say that mod of sine 2x is equal to positive sine 2x when x is greater than 0 but less than pi by 2. That is x belongs to this interval, that is 0 to pi by 2. right? Okay, now let us come to this inequality. Now see here, sine 2x is less than 0. It means sine 2x should be a negative quantity, and this happens when this 2x, it lies either in the third quadrant or in the fourth quadrant. So we can now write 2x is greater than pi, because now we have to go like this, that is pi to 2 pi, and here we have 2 pi. So when 2x, it lies between pi and 2 pi, then sine 2x is less than 0, that is it is negative. Now again, dividing throughout by 2, we have pi by 2, and here we have x, and here we have simply pi, right? So now we can say that mod of sine 2x is negative of sine 2x when sine 2x is less than 0, or we can now write here x greater than pi by 2 but less than pi, right? So we can now write x belonging to the interval that is pi by 2 to pi, right? Okay, so now let us come to this one. Here we have sine 2x is equal to 0. Right? Now this is a trigonometric equation, and we know that sine theta is equal to 0 when theta is an integral multiple of pi. That is, theta is n pi, where n belongs to the set of integers. So here we can consider the general case. So sine 2x is 0 when 2x is equal to n pi, right? So x can be written as n pi over 2, where n is some integer, that is 0 plus minus 1 plus minus 2 and so on. So here we can now write a mod of sine 2x is equal to 0 when sine 2x is equal to 0, or we can write x is equal to n pi over 2. So if we here write the values of n, then we can conclude that when n is 0, then x is 0 times pi by 2, that is 0. Similarly, when n is 1, x is 1 times pi by 2 is equal to pi by 2, and similarly when n is 2, x is 2 times pi by 2, and here we have pi and so on, right? So this is the definition of mod sine 2x, right? So now let us quickly draw the graph of mod of sine 2x. So now here we have the x-axis and y-axis, and we know that the sine function, the range of sine function is from -1 to 1, right? So here since we have the mod function, so we have the graph of mod of sine 2x above x-axis, right? So here we can draw the graph of sine 2x like this. This is the graph of sine 2x, and similarly here we can we can draw the graph like this, and here we have plus 1, right? So here we are not going into the details of how to draw the graph of mod sine 2x. So this is the graph of mod sine 2x. So now we have just seen that a mod of sine 2x is equal to 0 when x is equal to n pi by 2. So taking n is equal to 0, 1, 2, minus 1, minus 2, we can get the corresponding values of x. So here x is 0, so here we have 0. Then for n is equal to 1, x is pi by 2. So here we have pi by 2, then here we have pi, and similarly when we take n is equal to say minus 1, then x is equal to minus pi by 2. So here we have minus pi by 2, and when n is minus 2, then x is equal to minus pi. So here this point is minus pi. So this is the graph of mod of sine 2x. Now let us find out the derivative of f of x at these points. So now let us first consider part A. So here we have to find the derivative at x is equal to pi by 4. Now see, this point x is equal to pi by 4, it lies in this interval, that is x belonging to 0 to pi by 2. So when x is equal to pi by 4, then f of x is equal to mod of sine 2x, and which is further equal to positive sine 2x, right? So when we have to find out the derivative at x is equal to pi by 4, then we have to see that this point lies in which interval. So here x is equal to pi by 4, it lies in this interval. So we have to take fx is equal to plus sine 2x. Now let us differentiate f of x. So f prime of x is equal to d by dx of sine 2x, right? So the derivative of sine 2x is 2 times cosine 2x. So this 2 is due to the chain rule, right? Okay, now taking x is equal to pi by 4. So f prime of pi by 4 is equal to 2 times cosine 2 times pi by 4. So now we have 2 times cos, here we have 2 pi over 4, that is equal to pi by 2. So here cos pi by 2 is 0. So we have here 2 times 0, that is equal to 0, because cos 90 is equal to 0. So the derivative, that is f prime of pi by 4, is equal to 0. So now let us find out the value of this function at x is equal to pi by 4. So f of pi by 4 is given by positive sine 2 times pi by 4, that is sine pi by 2. So the value of the function at this point is equal to sine pi by 2, that is equal to 1. So let us plot this point, that is pi by 4 comma 1, right? So here we have the point pi by 4, and here we have 1, right? Because the maximum value of sine 2x is positive 1. So this point, that is this point is pi by 4 comma 1, right? And here we have seen that at this point the derivative is equal to 0, and we know that the derivative represents the slope of the tangent at the particular point, and here the point is pi by 4 comma 1, and the derivative is 0, that is f prime of pi by 4 is equal to 0. So the tangent at this point should be parallel to x-axis, because the derivative is equal to 0, and we know that the slope is defined as m is equal to tan theta, and here the slope is 0, so theta must be equal to 0. So the tangent at this point must be parallel to x-axis, because the derivative at this point, that is pi by 4, is equal to 0, right? So the derivative of this function at x is equal to pi by 4 is equal to 0, and from here we can conclude that the derivative at this point should be parallel to x-axis. So now let us consider the part B. So here we have to find f prime of 2 pi over 3. Now see, this angle, that is x is equal to 2 pi by 3, is it can be written as 2 over 3 times pi radian is equal to 180 degrees. So this is 3 times 60. So this is 120 degrees. And x is equal to 120 degrees or 2 pi by 3, it lies in the interval that is pi by 2 to pi, right? So now to get the derivative of this function, we have to consider f of x is equal to negative of sine 2x, right? So this is an important concept here, because x is equal to 2 pi by 3 is equal to 120 degrees, and it lies in this interval. So we can now write f of x is equal to negative of sine 2x, because this point, it lies in this interval, and when x lies in this interval, then f of x should be taken as negative sine 2x. Now let us differentiate both sides. So f prime of x is equal to negative d by dx of sine 2x, and as we have done earlier, this is negative, and here we have 2 cos 2x, right? Now let us substitute this point. So f prime of 2 pi by 3 is now minus 2 times cosine 2 times 2 pi by 3. So this is minus 2 cos 4 pi by 3, and here we can now write cos 4 pi by 3. We can split it, and we can write pi plus pi by 3, because pi plus pi by 3 is 4 pi by 3. So now we have minus 2, and from trigonometry we know that cosine pi plus theta is equal to negative cosine theta. So here theta is pi by 3. So we have cos pi by 3, and here we have a negative sign, right? Because cosine pi plus theta is negative cos theta. So we have minus cos pi by 3 and minus 2, and here we have minus, and cos pi by 3 is cos 60 degrees, that is half, right? And minus times plus, so we have simply plus 1. So the derivative, that is f prime of 2 pi by 3, is equal to plus 1. So now let us find out the value of the function at this point, right? So f of 2 pi by 3 is equal to minus sine 2 times 2 pi by 3. So we have minus sine 4 pi by 3. So here we can now write minus sine, and here 4 pi by 3 can be written as pi plus pi by 3. So we have minus, and again from trigonometry we know that sine pi plus theta is equal to negative sine theta. So here theta is pi by 3, so we have minus sine pi by 3. So this is here a minus minus plus. So we have sine pi by 3, and sine pi by 3 is square root of 3 over 2, right? So now we have the point, that is 2 pi by 3 comma root 3 over 2, right? And 2 pi by 3 is 120 degrees. So 120 degrees should lie between pi by 2 and pi, right? So 2 pi by 3, it lies somewhere here, and here we can write 2 pi by 3. So here we have the point. This point is 2 pi by 3 comma root 3 over 2, right? So now if we draw the tangent at this point, right? So when we draw the tangent at this point, it goes like this, right? And this angle should be equal to 45 degrees. because here the derivative is equal to plus 1, and we know that the derivative is m is equal to that is the slope is m is equal to tangent theta, and here the derivative is plus 1, so we have here a plus 1. So when tan theta is plus 1, then theta should be equal to pi by 4. So this tangent should make an angle of 45 degrees at with the x-axis, that is the positive direction of x-axis, right? So the derivative of f prime, that is the derivative f prime of 2 pi by 3 is equal to plus 1, and the tangent at this point, it makes an angle of 45 degrees with the positive direction of x-axis. So viewers, this is how we can find out the values of these two expressions, right? So let us summarize it. So here f prime of pi by 4 is equal to 0, and here the tangent is parallel to x-axis, and the value of f prime of 2 pi by 3 is equal to plus 1. It implies that the tangent at this point should be inclined with the x-axis, that is the positive direction of x-axis, at an angle of 45 degrees, right?